Hello, IM3 students. Today we're going to continue 10.1 and finish that lesson. So we're going to do day 3 today, which is continuing finding the inverse of quadratic or cubic functions. So today, since we are wrapping it up, we are actually going to be working with the cubic function. So you will be able to identify the inverse functions for cubic functions today. And let's take a look at what a cubic function looks like. Remember, we have learned in the previous module that a cubic function actually has a shape of like an S, like a snake, or an N. And so this is the graph for an x cubed function. And believe it or not, the inverse for an x cubed is actually the cube root. So that's how you undo the cube function. So therefore, the graph of a cubic function looks like this sideways. So because it is a reflection. So you can see a better picture over here that I have used decimals to graph. So here is the cube function, x cubed, and here we have the cube root of x function. So it looks like it is an exact mirror image across this line, y equals x. So since we know now how the cubic and the cube root functions are related now, we are ready to take a look again. This is another picture of the cube function and the cubic function. So cube and cube root are inverse functions of each other, and you see it here. It's an exact mirror image. So here we have a function that is cube originally. So we're going to do the same thing that we did on day 1. We're going to go through and find the inverse, and then we're going to confirm. So just for the sake of clarification, as you can see, the difference between a square function and a cube function is that the x squared is a many to one function, which means we need to restrict the domain. But as you can see for the cube function, it is not a many to one. Everything is unique. So we will not have any restrictions for the domain. So as you can see, that's why in the problem here, you do not need to restrict the domain. So in fact, the domain and the range for cube root and cube are all reals for everything. Cube root also all reals for the domain and the range. So that's actually very easy to remember, right? So we are not going to have to restrict the domain in this case. So we're just going to find the inverse and then confirm and then graph them on the same set of graphs. So that's pretty easy. So first we're going to find the inverse. So we're going to switch, we're going to start by rewriting it as a y instead of f of x, then switch the x and y. And then we're going to solve for the new y. So dividing by 0.5. And we got y squared is equal to, let's write that over here. So we got y squared equals x over 0.5. And then taking the square root. I've been doing this wrong. It's actually x cubed. So we're going to take the cube root of both sides. And so now we got y is equal to the cube root of x over 0.5. So it's very easy to get the two confused. So make sure that you do it carefully, as I just made a mistake earlier. So it's y equals cube root of the x over 0.5. Again, we do not need to restrict the domain because if you try actually taking the cube root of any number, it's always going to give you an answer. It's never going to give you an error with any number that you input into the cube root. So therefore, that is why we do not need to restrict the domain, and so that makes life easier for us. But we still need to confirm that this is in fact the cube root, the inverse. So because you're calling this the inverse of the function, right? So we need to verify. So we're going to verify it using the same method that we did before. So the f inverse of f of x, we're going to start with the inverse, which is the cube root of x over 0.5. And what do we put inside? We put f of x, right? 0.5 x cubed. So the 0.5s are going to cancel out. So you got the cube root of x cubed, and the cube root and cube cancels out, and we get x back. So we're going to verify f of f inverse of x again. So we're going to start with 0.5 the function x cubed, and what do we put inside? We put f inverse. F inverse is over here. So we have the cube root of x over 0.5. Cube root and cube cancels out, and we got 0.5 times x over 0.5. And then the 0.5's cancel out, so you get x back. And that's how you know you have verified it. Once you verify it, for today's sake, you're going to again enter these two functions, the original and the inverse, into the decimals calculator, and to verify that they are in fact mirror image of each other. And that's the end of the problem. And let's take a look at another one. So you can go ahead, if you already know how to do this, pause the video, try it first before you actually look at the answer, and you can use decimals to help you. So again, we have a cube function. So let's go ahead and start by finding the inverse of the cube, switching the x and y again. And it should become easier now because you've done this for a little bit. Finally, we got the cube root, so we're going to take the cube root. So undo the cube by taking the cube root, and we have f inverse of x is equal to the cube root of x plus 2. Again, we do not need to restrict the domain, so we're just going to confirm that we have the correct inverse. So we're going to start with f inverse of f of x. So we're going to start with f inverse, which is the cube root of x plus 2. And what do we put inside the parentheses? We put f of x. So that's x cubed minus 2. And we're going to just cancel out the 2's first, and then you've got cube root of x cubed. And that cancels out the cube and the cube root. We got x by itself. So that's one way. And then we're going to go f of f inverse of x. So we're going to start with f of x, which is x cubed. And what do we put inside the parentheses? We put the inverse. That's the cube root of x plus 2. The cube root and the cube cancels out. We got x plus 2 minus 2, and the 2's will cancel out. Gives us an x nicely back. So that's how we know we found the correct inverse. So this is in fact the inverse. Make sure you guys show work the way that I've been showing you guys how to do this. Every piece of information is important for you to show your thought process. So make sure you guys follow through. And then we have entered the inverse, the function and the inverse in the graphing calculator. So go ahead and go to decimals and make sure that your graph looks like a mirror image. And that is two problems that we've done together. So make sure you pause the video at this time and try one on your own first, to make sure you know how to do this from beginning to end before you look at the answer. And here we go. So we're going to find the inverse by replacing the y, and then we're going to switch the x and y and solve for the new y. So we got y cubed equals x over 2, taking the cube root of both sides to get rid of that cube. So we got f inverse of x is equal to the cube root of x over 2, and that is my inverse, but we got to verify it. So we're going to go f inverse of f of x equals, I'm going to start with the f inverse, which is the square root of x over 2. What do we put inside the parentheses? F of x, right? So that's 2x cubed. And then we're going to cancel out the 2. So we got this cube root of x cubed. Cube and cube root cancels out. That gives us x back. Perfect. F of f inverse. Got to come back. So we got f of x, which is 2x to the third. What do we put inside the parentheses? Inverse, which is right here. So cube root of x over 2. Cube and cube root cancels out. We got 2 times x over 2. The 2's cancel out, and that gives us x back. So now we have verified that that is in fact the inverse. And go ahead and enter the function and the inverse into decimals to verify that they are the mirror image of each other. And so therefore, that is the end of the modeling with finding the inverse. But we're actually going to get into the real world situation, so kind of like combining 2 days into one here. So again, this is a review of finding the inverse of the cubic model instead. So again, instead of the f of x, it's y of x, and then the inverse is going to be x over y, x of y, and we are not solving for, we're not switching the variables, but we're just rewriting the function as inverses of each other. So here we have a function a equals 4 over 3 pi r cubed. Does anybody remember what this is? This is actually a volume function, but it's a cubic function, but it deals with the surface area of a sphere. So that's the surface area formula for finding the surface of area of a sphere, and we are asked to find the inverse function. That means we're going to solve for r in this equation and then find the radius with the given surface area. So we're just only talking about general terms. We're not given any specific numbers here, so we're actually just going to solve for r. The first thing that I want to get rid of is actually that 3 right there. So we have an ugly 3 right there on both sides of the equation. So we have to get rid of that. So canceling the 3 out by multiplying 3 on both sides, we have 3a equals 4 pi r to the third. And now we have a nice and even problem with no fractions on either side. I know you guys don't like fractions, so that's why we are getting rid of that fraction to start with. And the next thing we're going to do is unfortunately bringing the fraction back. So we're going to divide it by 4 pi on both sides. So we got r cubed equals 3a over 4 pi. Finally, we just want to get r by itself, right? So we're going to take the cube root of both sides. So we just have r equals cube root of 3a over 4 pi. You can say that this is r or r as a function of a. Either way, it means the same thing. So this is the general formula that you can use to solve for the radius in terms of the surface area. And I'm going to give you guys a chance to try this before you look at the answer. So go ahead and try solving for the variable r again. So we got m equals 44 over 3 pi r cubed gives the mass in grams of a spherical lead ball with a radius of r centimeters. Find the inverse r of m to find the radius when the mass is given. So again, we're going to solve for r. First thing, again, you can start by multiplying by 3 on both sides to get rid of that 3 again. So that will get rid of 3. So we have 3m equals 44 pi r cubed. Next thing, I need to divide it by 44 pi on both sides. And that will get rid of that. We got r cubed equals 3m over 44 pi. And then finally, we're going to take the cube root of both sides because we want to get rid of that cube. So r is equal to the cube root of 3m over 44 pi. You can say it's r or it's r of m. They mean the same thing, but here is the equation to look for the radius when the mass is given. And here is a discussion question. What is the general form of the inverse function for the function y equals ax cubed? State any restrictions for the domains. So because we know that this is a cube function, the inverse is going to be dealing with the cube root. So we're going to start with the equation, and basically we're just going to solve like pretending we're looking for the inverse, right? So the first thing you want to do is divide it by that a. So you got x cubed equals y over a. Finally, you're going to take the cube root of both sides, and you have x equals cube root of y over a. And then we can look for the cube root function. So this is basically how you can find, and of course one of the steps that you need to involve is switching the x and y, so it looks like the variable x is the equation. So do we have any restrictions for the domain? Remember, we had a discussion that for the cube root you can take the cube of any number, so there's no restrictions. So it's actually all reals for the domain. So the domain is all reals, there's no restrictions. And that's the end of the lesson for today. Go ahead and get started with your assignment by logging into Google Classroom. Have a nice day.